This is First Coast Math Clinic with the SAT practice test number 1, no calculator. So all materials for this that I'm going to be going through can be found on collegeboard.org, and I'm going to post a link for the test itself and the answers on my YouTube site. So we're going over the practice test number 1, no calculator. This test is 20 questions, is 25 minutes long, so it works out to about 1 minute and 15 seconds per question, so a little over 1 minute per question. So the problems on the no calculator and calculator math test are broken up into 3 categories. There's the heart of algebra, passport to advanced math, and additional topics. Heart of algebra has topics such as linear expressions, functions, systems of equations, and inequalities. So kind of basic, your basic algebra concepts and topics. Passport to advanced math, some more complex topics, things like quadratic and exponential functions, polynomial expressions, and function notation, some more advanced, more complex topics. Additional topics are a little more geometry-based topics, things like angles, circle properties, area and volume, so again, more geometry-based. The majority of the problems that we're going to see in the calculator and no calculator test are going to be in the heart of algebra and passport to advanced math, right? So that's where the majority of the questions are going to come from. So since we're working on the no calculator section, think of the types of math problems that you could solve without a calculator. A lot of them are going to be manipulating expressions, manipulating equations, isolating variables, things like that, right? It's not going to be a lot of complex calculations where you have to do large multiplication, division, squaring, working with exponents, dividing complex numbers, dividing complex decimals, things like that. So if you find yourself doing some of those operations, you're probably off on the wrong track. It's going to be more manipulating expressions, equations, working with some math properties and manipulating some expressions, equations, things like that. Okay. All right. Let's start going through this test. Okay, so this is the practice test for the no calculator section for the math test on the SAT. It's section 3 on the SAT, and this is the first part you'll see when you take this test. So I encourage you guys to get yourself familiar with what this test looks like. So first thing you'll see, time limit. So you've got 25 minutes and 20 questions. Let me get my highlighter here. So 25 minutes and 20 questions. And this is again section 3, so make sure you're bubbling in the correct section of your answer sheet. Then for questions 1 through 15 is going to be bubble in, and then 16 through 20 is going to be short answer. Not short answer, it's going to be grid in. So we'll look at those in particular. Specific notes. You can use any space available in your test book for a scratch work, so you could write on the test book. Again, I get that question quite frequently, so you can do your work right on the test book. Again, calculator is not permitted. All variables and expressions represent real numbers unless otherwise indicated, so your solution is going to be real numbers unless they tell you. Everything's drawn to scale. Figures are in a plane. And then again, real numbers. Okay, so you get this reference sheet, so you get a good amount of formulas here for area and volume, so you could reference this, and then you get some information regarding like arcs for circles, radians, and triangle angle measures. Okay, so you get some information to reference at the beginning of the test, so it's decent information to reference, right? All right, so let's get into our test and our problems and start solving some of these. So for number one, we've got if x minus 1 over 3 equals k and k equals 3, what's the value of x? So we know k is equal to 3, so we're going to just do some substitution, put that 3 in for k. And then solve for x, because that's what it's asking us to do, right? We want to find the value of x. So let's undo this division. Times 3 times 3. 3's cancel out. I get x minus 1 equals 9. Add the 1. add the 1, 1's cancel out, and I get x equals 10. Okay. Now keeping in mind we've got about a minute and 15 seconds per question, so we got to kind of keep that in mind as we're going through and solving each problem. We don't want to spend too much time on each problem. All right, for number 2, so we got I equals the square root of -1. So we've got our imaginary value here, I equals square root of -1. What is the sum of 7 plus 3i plus -8 plus 9i? So we can almost treat this like terms, right? So the 7 and the -8, we want to add those together, and then we want to add up the 3i. I'll use my pen for this. The 3i and the 9i. So we can do it like this, right? So let's write 7 plus 3i plus -8 plus 9i, and plus we're adding. So 7 plus -8 is going to give me -1. 3i plus 9i is going to give me a positive 12i. So that's our solution. So I had -1 plus 12i, so we should get A there as our answer. All right, number 3. Saturday afternoon, Armand sent M text messages each hour for 5 hours. So let me underline this in red. M text messages for 5 hours, so that's Armand. And then Tyrone sent P text messages each hour for 4 hours. Which of the following represents the number of messages sent by Armand and Tyrone on Saturday afternoon, right? So we basically want to represent Armand's messages plus Tyrone's messages, right? So Armand sent M text messages each hour for 5 hours. So how do we represent M text messages each hour for 5 hours? Well, that's going to be 5 times M, right? If you sent M text messages each hour for 5 hours, so we have to multiply the number of text messages he sent, M, times the number of hours he sent them, 5, plus Tyrone sent P text messages for 4 hours, so the number of text messages he sent, which was P, times the number of hours he spent sending them, which was 4, so 4 times P, so we get 5M plus 4P, so our solution should be C here. All right, moving on to number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that needs repairs, and the number of phones she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D. So let's underline that. So P equals 108 minus 23D, and that's going to be the number of phones she has left to fix at the end of each day. And we got some additional information here. So P is the number of phones left, and D is the number of days she has worked that week. What is the meaning of the 108 in this equation? So what does that 108 mean in this equation? So we've got P equals 108 minus 23D. So we know that P is the number of phones left, so P is our phones left, and then D, days worked. So what's the meaning of 108 in this equation? So this equation may look kind of similar. We've got our our change here. So this is basically our equation in slope-intercept form. So y equals mx plus b, or we can kind of rearrange this b plus mx. But in this case, we're decreasing here, right? Because the number of phones is decreasing by 23 per day, right? So that 23 are the number of phones she fixes per day times the number of days. So what is that? 108. Well, that's the starting amount. That's how much she's starting. She starts with each week, right? So she starts with 108 phones per week. Each day, it decreases by 23. So where do we find that? Kathy will complete the repairs within 108 days. Well, it's not 108 days, so that's not going to be it. Kathy starts each week with 108 phones to fix. Well, that's it, right? Kathy starts, the starting amount each week is 108, so it looks like it's going to be that. Let's just double check C and D. Kathy repairs phones at a rate of 108 per hour. Well, we know our rate is per day, so it's not C. And Kathy repairs phones at a rate of 108 per day. Well, we know our rate is 23 phones fixed per day, so it's not going to be D. So our answer should be B here, right? Remember this, that is our kind of our B value in our slope-intercept form. So this is like B minus mx. So that's our starting value. Okay. All right, let's go on to number 5. All right, for number 5, which is equivalent to the expression above? So we're subtracting this entire second quantity here. So what we can basically do is kind of pretend like there's like a negative, or there is a -1 here, and distribute that -1 inside the parentheses. So all of our signs here are going to switch. So this is going to become a plus, this is going to become a minus, this is going to become a plus. All right, so plus minus plus. Now we can group our like terms together. So I'm going to rewrite this down here, grouping our like terms together. So our like terms have the same variable raised to the same power. So I'm going to start with the x squared y, and like term is going to be, let's do, you know, I'm going to write this out just so it's a little bit clear to everybody. So I don't have to squeezing this in. So let's do this. So I'm just going to rewrite this second part here like this. So I'm distributing this negative inside the parentheses. Okay. Clean this up a little bit. So our signs are going to switch. Negative times negative is a positive. So I'm going to get positive x squared y. Negative times a positive 3xy squared is going to give me negative 3xy squared. -1 times negative 3y squared is going to give me positive 3y squared. So now let's group our like terms together. So our x squared y and x squared y are like terms. Our negative 3xy squared and the plus 5xy squared are like terms. So I'm including the sign with each term. And the minus 3y squared and the plus 3y squared are like terms. Okay, so let's rewrite this, grouping our terms together. So I'll put the x squared y plus x squared y minus 3y squared plus 3y squared plus 5x y squared minus 3x y squared, x squared y plus x squared y, so our coefficients are 1 and 1, so we're going to get 2x squared y, negative 3y squared plus 3y squared, so these cancel each other out, we're going to get 0 here, 5xy squared minus 3xy squared gives us plus 2xy squared, so we get 2x squared y plus 2xy squared, so our answer should be C here. All right, so the big thing I want you guys to pick up from that is we distributed this minus sign, all right, this -1 into the parentheses, changed the signs of everything in the second quantity. So we got opposite signs. Then we just combined our like terms, okay? All right, let's go to number 6. So we're number 6. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a. So height h in terms of boy's age a in years between ages 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So we've got h equals 3a plus 28.6. So again, this reminds us of our equation y equals mx plus b, right? It's in the same form. All right, so this is our starting value. That's where we start. This, that 3, that's our change because the m is our slope or our change, our rate of change. So if we're looking for the estimated increase in inches of a boy's height each year, it would have to be that 3 per year. So our answer is going to be A here for number 6. And again, if it takes us a little bit longer to do examples like number 5, then number 6 is where we're going to kind of make up some time because we can look at number 6 really quickly and figure out, well, our increase right from this equation is going to be, our answer from this equation is going to be B3, right? That's our increase per year. All right, number 7, the formula above gives the monthly payment M needed to pay off a loan P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Okay, so this looks really complex, but basically all we're doing is we want to get that P by itself. So let's think about this, right? Let's think if our equation was this. M equals A times B, or A over B times P, right? And we wanted to get that P by itself. Well, what would we do here to get that P by itself? We would multiply by B, multiply by B, all right, so the B's would cancel out. So we'd have B times M equals A times P. Then we would divide by A, A's cancel out, and we get M times B over A. We could write B over A times M equals P. That's exactly the same thing we're going to do here. Just, let me get my pen. This A is this entire numerator here, okay? This B is this entire denominator here. So we're doing the exact same thing. We just have a bit of a more complex equation to work with, okay? So let's get into this. So we want to get that P by itself, and I'm going to write out part of this just so you guys can see what I'm doing, right? So I want to get that P by itself. I'm dividing by everything that's here. So I want to multiply by 1 plus R over 2, 0, n minus 1. Okay, so I'm multiplying both sides by this denominator, 1 plus r over 1,200 to the n power over 1. All right, so these values are going to cancel out and cancel out on the right, so I'm just left with this p. Okay, so I've got p right here. Now I've got to take care of this numerator. So now I can divide by this r over 1,200 times 1 plus r over 1,200 to the n power. Okay, I'm going to pause this and just put it over here so you don't have to watch me rewrite it. All right, so I divided both sides by this numerator. Okay, and again, so now these values cancel out, and all we're left with is p on this right side, and we've got m on the left side times these two quantities. So let's match this up, and I believe we should get b as our answer. All right, so we've got 1 plus r over 1,200 to the n power minus 1 in our numerator. Denominator is r over 1,200 times 1 plus r over 1,200 to the n power times m. Okay, so again, we look at this, it looks really complex and difficult. It's just assessing our ability to manipulate this formula, look at this equation, and isolate that value p. Okay. All right, let's get to number 8. So for number 8, we've got if a over b equals 2, what is the value of 4b over a? So let's work with this a over b equals 2 and see if we can get it to look like 4b over a. Okay, first thing we notice is that b is in the numerator, so I'm going to bring that b up to the numerator by multiplying and multiplying by b, so b cancels out. So a equals 2b. Now, I notice I've got a 4 here. I want 4 instead of 2. Well, how do I make that a 4? I can multiply both sides by 2 and 2. So whatever I do to the left side, I have to do to the right side. So I can multiply both sides by 2 and 2. So now I get 2a equals 4b. So again, I'm trying to get this right side to look like this equation. Okay, so I've got the 4b in the numerator. So now I just want a in the denominator. Well, how do I do that? Let's divide by a, divide by a. A's cancel out. So I get 2 equals 4b over a. And what's the value of 4b over a? 4b over a is going to be 2, so my answer is going to be C. Okay, so we notice here, this basically just tested our ability to manipulate this equation and write it in this form. Okay, so do we know that we can get that b in the numerator by multiplying both sides by b? We can multiply both sides by 2 and 2, move a from the left to the right by dividing by a. So that's what it's looking for here. All right, for number 9, what is the solution xy to the system of equations above? So we're solving this system. So let's figure out what method we want to use to solve this system. And kind of noticing, looking at our x's, right, I've got a coefficient of 3 here for this x and a coefficient of -1 for this x. I think elimination may be the best method, right? So I can rewrite this. Let's keep that top system as it is. I'm going to rewrite this as -1x plus 2y equals -19. I'm going to multiply this bottom equation by a +3. So now we get negative 3x plus 6y equals negative 57. So now I'm going to add, I'll just write that top equation down here. So now I'm going to add my two equations because my negative 3x and positive 3x are going to cancel each other out. I'm going to get 10y equals negative 80. Divide by 10, divide by 10, and I get y equals negative 8. So once I get that, and I'm pretty confident with my solution, I don't have to go any further because I notice the only solution with a negative 8 in the y position is going to be B. But let's say that you it wasn't that clear. To get the x value, let's say we would take that negative 8, put it back in. So I'm going to put that negative 8 back in, maybe in the top equation. So 3x minus 32 equals 23. So let's add 32, add 32. We're going to get 3x equals 9, divide by 3, and x equals 3. So we get, again, that x value there. So again, our solution here, we're dealing with some multiplications. It's the stuff we're doing isn't so difficult that we couldn't do it without a calculator, right? Most complex operation here is like that 3 times negative 19 and then some addition. So it's nothing we really couldn't do without a calculator. All right, number 10, for the function g defined above, a is constant and g of 4 equals 8. What is the value of g of negative 4? Well, to figure that out, we have to figure out what this a value is. So let's use this information to figure out what a is. So we know that g of 4 is equal to 8. So we can rewrite this as 8 equals a times 4 squared plus 24, right? Because that 4, that's our x value. 8, that's our g of x. So 8 equals 16a plus 24. Subtract 24. Subtract 24. We get negative 16 equals 16a. Divide by 16. 16. And we get a equals negative 1, right? So we figured out what a is equal to, right? That's our first step. So now we can rewrite our function. So our function should be g of x equals negative 1 x squared plus 24. So we want to find g of negative 4. So g of negative 4 equals negative 1. There's negative 4 squared plus 24. So I'll get negative 1 times 16 plus 24. Negative 1 times 16 is negative 16 plus 24, and we're going to get 8. So our answer here should be 8. For number 11, the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively. 11 weeks after July 1st, during the last summer, what was the price per pound of beef when it was equal to the price per pound of chicken? All right, so we've got another system we could work with, but we want to know what was the price per pound of beef when it was equal to the price per pound of chicken. So our value for beef and chicken were equal to each other here. So beef and chicken were equal to each other. So So we can set up an equation and set that price, actually, for beef, 2.35 plus 0.25x equal to 1.75 plus 0.4x, right? So the price of beef is equal to the price of chicken. So what was the price per pound of beef when it was equal to the price per pound of chicken? So this is going to solve for x, but x is going to give us weeks. So let's figure out the weeks first, then we could figure out the price. So let's solve this. I'm going to subtract the 0.25 and 0.25. So 2.35 equals 1.75 plus, this is going to give us 0.15x. Now let's subtract the 1.75, 1.75, and we're going to get 0.6 and 0.15. So we divide by 0.15 and 0.15, and x is equal to 4. So it's 4 weeks. Okay? So, well, it doesn't make sense in the context of our answer because we got 4 weeks, but our answer is going to be in dollars, right? So what we just figured out is after 4 weeks, the price was equal, but we want to know what was the price per pound of beef when it was equal to the price per pound of chicken. So we've got to take that 4. So we have to take that 4 and put it back in here, in for x, and solve for b. All right, so let's do that. So this one's going to take a little bit longer. Let me undo all that highlighting. So let's take b is equal to 2.35 plus 0.25 times 4. Now, here's where we can make up a little bit of time. 0.25 times 4. Well, it's 25 cents times 4. A quarter times 4 is going to give us 1, plus 2.35 is going to give us 3.35. So our answer here should be D. Okay, so don't get confused by that. We know that it's telling us the price per pound of beef and chicken are equal to each other. What was the price per pound of beef when it was equal to the price per pound of chicken? So they're equal to each other. So we're setting up this equation, finding the number of weeks first, and then substituting it back in to find that price B. All right, let's go on to number 12. All right, for number 12, a line in the xy plane passes through the origin. So we know our origin is just 0, 0, and has a slope of 1, 7. Which of the following points lie on the line? So we know our slope, our change in y, over change in x. So let's set up a table to figure this out. So xy, starting at 0, 0, our change in x. So if our slope is 1 over 7, that's our change in y, it's our change in x. So we're adding 1, so we're going to get 1, and then 2. We're adding 1, 1, 1, and then 3. Adding 7, and then 7, so we're going to get 14, and then another 7, so we're going to get 21. So we've got 0, 0, 7, 1, 14, 2, 21, 3. So looking what points fit into or what points are on our line, it should be this 14, 2. All right, so that's going to be on our line. A common mistake, I think, here, if you kind of put these in the wrong order, you may get that 1, 7. So just make sure you have this in the right order. You're listing your X and Y values in the correct spot. So you should have 14 and 2 here. All right, so good number 13. All right, so number 13 is a little tricky, so it's going to take a few steps. So let's get through this one. So first thing we want to do is we want to multiply. And let's think about this. We want to simplify our denominators. So we've got to multiply. And I want to figure out, well, what can I multiply 1 over x plus 2 by to cancel out that denominator? Well, I can multiply by x plus 2, right? Because if I get x plus 2 in that numerator, x plus 2 over x plus 2 are going to cancel out. But whatever I multiply in the numerator or denominator, I have to multiply in the numerator. So I have to put x plus 2 in the numerator. Now, same thing here. I've got 1 over x plus 3. I want to cancel out this fraction here. So what can I multiply 1 over x plus 3 by to cancel it out? I can multiply by x plus 3, because if I get x plus 3 over x plus 3, that just simplifies to 1, right? But whatever I multiply the denominator by, I have to multiply the numerator by. So I have to put the x plus 3 in the numerator, okay? So let's do this out, right? So next step, 1 times x plus 2 times x plus 3 just gives us x plus 2 times x plus 3, okay? So that's our numerator. Denominator is a little bit different. So denominator, we're going to have x plus 2 times x plus 3 over x plus 2 plus x plus 2 times x plus 3 over x plus 3. So what I basically did, let's see if I get my highlighter working, is take this quantity and distribute it. So I multiplied it by the 1 here, and then multiplied it by the 1 here, right? So we multiplied by each of these quantities. So now what we can do is do some simplifying. So I've got x plus 2 over x plus 2, so I can cancel out the x plus 2 and the x plus 2. And I can cancel out the x plus 3 and x plus 3. And in the numerator, I can FOIL this, right? So I have x plus 2 times x plus 3. So we can do FOIL. So first, x squared, outer, x times 3, inner, 2 times x, last 2 times 3. So that's our numerator. And our denominator, we have x plus 3 plus x plus 2. So in our numerator, let's finish simplifying. X squared plus 5x plus 6. In our denominator, x plus x is 2x. 3 plus 2 is 5. And we get B as our answer. Okay? So the trick here is looking at these fractions and figuring out, well, what do we have to multiply to eliminate those fractions? We've got x plus 2, so we said, okay, I want to multiply the denominator and numerator by x plus 2. I've got x plus 3. I have to multiply the denominator and numerator by x plus 3, and then distributing them, canceling them out, FOILing, and then simplifying. All right, let's look at number 14. So for 14, if 3x minus y equals 12, what is the value of 8 x over 2y. 8 to the x power over 2 to the y power. So let's see if we can rewrite this a little bit. So we've got 8 to the x power, and see we work with some of our properties of exponents. We know that 8 is just 2 to the third power, right? And we've got 8 to the x power. So 8 to the x power is going to be 2 to the third x to the 3x power, right? So this 8, do that again, this 8 to the x power over 2y, we can rewrite as 2 to the 3x over 2 to the, try that again, 2 to the y. So now we have the same bases, 2 and 2. We know that when we have the same bases and our exponents, we can subtract our exponents, right? So we can keep that base 2, and this is basically 2 to the 3x minus y. Because think about, like, if this was x to the 10th over x to the 8th, right? To simplify this, we would do x to the 10 minus 8. That's the same thing we're doing here, right? We have the same base, x and x, same base, 2 and 2. We're subtracting our exponents, x to the 3x and y, right? And that looks a lot like what we have here, 3x minus y. So 3x minus y is equal to 12, so we can replace that 3x minus y with 12, so we're going to get 2 to the 12th power. Our answer here should be A. So this is testing our ability to rewrite expressions. So when you see something like this, think about how you can maybe like manipulate these expressions. Like if you get like 8 to the x power, think about, okay, you know, you can rewrite that 8 as like 2 to the third power. You can rewrite it as an exponent. Think about stuff like that. All right, let's look at number 15. All right, so for 15, if ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of a, and a plus b equals 8, what are two possible values for c? So this could be a little bit tricky, but let's first start with this expression. All right, so let's start with that ax plus 2 times bx plus 7, and let's FOIL this out, right? So we want our first, so it's going to give us ab x squared outer plus 7 ax inner 2 bx last 14, all right, and that equals 15x squared plus cx plus 14. Okay, so for all values of x, and a plus b equals 8. So what are two values for c? So what we can do is we know that, well, a plus b is going to equal 8. So from our equation, we also know that if we multiply a times b together, we have to get 15. So our values for a and b have to be 3 and 5. Our question is, well, is a3 or is a3 and b5, or is b3 and a5? So that's what we're going to figure out. So what we're going to do is we're going to do this twice. We're going to set up one equation where a is 3, b is 5, and we get 8. We're going to set up another equation where a is 5, b is 3, we're going to get 8, and we're going to figure out what that c value is, because that middle value is going to change depending on the value of a and b. So let's do this, and you'll kind of see what I'm talking about. All right. So let's start with a is 5 and b is 3. Okay. So a is 5. I'm going to have 5 times 3 squared plus 7 times 5 x plus 2 times 3x plus 14. So I want to find c. C is this middle value. Okay? So I get 15x squared plus 35x plus 6x plus 14. And I get 15x squared plus 41x plus 14. So x, not x, excuse me, should be c here is 41. So if a is 5 and b is 3, then c is 41. So now let's switch. Let's do a is 3 and b is 5. So I'm going to substitute back into that same equation and just change the values. So now I'm going to have 3 times 5 x squared plus 7 times 3 x plus 2 times 5 x plus 14. So comparing this, right, I'm multiplying different values here. Instead of 7 times 5, I'm multiplying 7 times 3. Instead of 2 times 3, I'm multiplying 2 times 5. And I get 15x squared. So this value and this value are the same, but these values here are going to change. So I get 21x plus 10x plus 14. And that middle value is going to be, because that's all I really care about, is going to be 31x. That's my c value. So c here is 31. So my c values are 41 and 31, and my solution should be D. Okay? All right, let's move on to number 16. And this starts our grid in section. So on this page, they give you some directions on how to grid things in. Things are right aligned. It's not necessary that you write your answer in the top, but it is suggested. Mixed numbers, one of this is kind of important. Mixed numbers such as like 3.5 have to be gridded in as decimals or improper fractions. So if you grid in 3 1/2, it's going to be interpreted as 31/2, not 3.5. So make sure if you have mixed numbers, you convert those to improper fractions or convert them to decimals, right? So decimal answers that have more digits than the grid can accommodate may either be rounded or truncated, but you have to fill the entire grid. So if you have like, something like 2/3, you could enter like 0.6 and then 0.6 repeating, or 0.66 and then 7. So fill in that entire grid. Okay. But again, this is something it's useful to kind of go through just to make sure you're gridding things in and bubbling things in correctly. So again, left align or right align doesn't really matter. So again, you can start on the right or the left side. It doesn't really matter which direction you align. All right, let's get into some of these problems. So for number 16, if t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? So let's solve for t. So I'm going to add 4. Add 4. So I've got t squared is equal to 4. And then I could take the square root and square root. So I'm undoing squaring. Square root of 4 is going to be positive and negative 2. The important information, reading the directions here, t is greater than 0, so our answer is only going to be that positive 2. So t is going to be equal to positive 2, and that's what we would grid in. For 17, a summer camp counselor wants to find the length x in feet across the lake as represented in the sketch above. So we're looking for this distance here. Let's do this in, we're looking for this distance here, that's our x. The length represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet. So let's label these as we have them. So AB is 1,800 feet. 1,400 feet, so EB is 1,400 feet. BD is 700 feet. And CD is 800 feet, respectively. Segments AC, DE intersect at B, and angle AEB and CDB have the same measure. So AEB, so my angle here, and CDB here have the same measure. What is the value of X? So we're using similar triangles. So this is our kind of that other section or geometric topic of questions that we're going to be working with. So we've got congruent angles here and here, and we have congruent angles here and here. So we can use our angle-angle similarity property, and if we're kind of arranging this triangle, we can say that triangle ABE is similar to triangle CBD. So we're matching up our corresponding angles. A corresponds to C, B corresponds to itself. So this angle here, do these in colors, so this angle here and here correspond. This angle here and here, C and or E and D correspond. By angle-angle similarity. So what that allows us to do is to make up some proportions, right? So we can say that AB corresponds to CB. So I'll write this down here. AB corresponds to CB. So I'll do this in the same color, AB. And CB, so here and here. And actually, let's figure out what sides we want. Let me double check that. And you know what, since we don't know this side, we don't know BC, let's not use that relationship. So what we can do instead, get rid of that, get rid of that. What we can do instead is let's do AE. So I'll clean some of this up. So we'll do AE first and last, and CD first and last. So this side right here, AE and CD first and last. So those two sides are going to correspond. And then we can do EB. EB and BD. So we'll do BE and BD. Okay, so we'll do those sides. So we can use that to set up our proportions. So AE, that's going to be X over CD, which is 800. BE, 1400. BD is 700. So now we got a proportion. We can cross multiply. Actually, we can make this a little bit easier. We can cancel out some zeros here. And 14 over 7, if we want to make that even easier, we can rewrite this as X over 800 equals 2 over 1. Cross multiply, and we're going to get 1600 as our answer. So the important part is setting up your proportion, right? So think your similar triangles, we're writing our corresponding parts. AB corresponds to CB. BE corresponds to CD, and then AE corresponds to DC. Okay. All right, let's look at number 18. According to the system of equations, what is the value of x? So let's solve our system. So if we want to solve for x, we should eliminate y to get x by itself. My coefficient here is 2, so I'm going to multiply that top equation by -2. So I'm going to have -2x minus 2y equals 18. And that bottom equation is going to be x plus 2y equals -25. Now I can add, and add. So I'll get -1x equals 18 plus -25 is going to give me -7. So -2y plus +2y, they cancel out. Divide by -1, divide by -1, and we get x equals +7. So our answer here is going to be +7. All right, 2 more problems left. Let's look at number 19. In a right triangle, one angle measures x, where sine of x equals 4/5. What is the cosine of 90 minus x? So let's think of our sine, cosine, and tangent. We know SOHCAHTOA, sine is opposite over hypotenuse, so sine of x is opposite over hypotenuse. Cosine of x adjacent over hypotenuse. So if we set up our triangle, all right, if x is here, opposite over hypotenuse, so we would have opposite here and hypotenuse here, 4/5. And we want to figure out cosine of 90 minus x. Well, if we represent our angles as x, this is 90. This angle right here is going to be 90 degrees minus x. Okay, so we're actually finding the cosine of this angle right here, which means this is my adjacent side, this is still my hypotenuse. All right, so my cosine, my answer is still here going to be 4/5. So my answer should still be 4/5 because it's referencing this angle right here, which is 90 minus x, which gives me my adjacent side 4, my hypotenuse 5. All right, let's look at number 20. So this is the last one. If a equals 5 square root of 2 and 2a equals the square root of 2x, what is the value of x? So let's take our 2a equals the square root of 2x and replace that a with 5 square root of 2. So I'm going to have 2 times 5 square root of 2 equals square root of 2x. So I get 10 square root of 2 equals square root of 2x. So let's get that 10 by itself. So let's divide by square root of 2, square root of 2. Square root of 2's cancel out, so I get 10 equals square root of 2 over square root of 2 times square root of x, right? Because that's square roots over the 2 on the x. Well, square root of 2 over square root of 2, that cancels each other out. That's just going to be 1. So I've got 10 equals square root of x. That's not square root of x, should be square root of x. Okay, well, I want to know what x is, not square root of x. So how do I undo taking the square root? I can square and square each side. So the square root of x squared is just going to give us x. Square root of 10 is 100. X is going to be 100. So number 20 is going to be 100. Okay. All right, so this is a long video on the no calculator portion on solving SAT problems. So I hope this helped you guys. If you like this video, leave a like, comment, and subscribe. I'm going to be putting more SAT and ACT problems up on my YouTube site. So again, if you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.